Okay. Welcome to our second presentation from T. Harris Environmental. And we invite you to also tune in to our third presentation at 2 o'clock, ergonomics at the office and working from home. And then the last session is infection control with respect to COVID-19 and cold and flu season. I will begin by making this presentation on prevention through design. And the question comes up is, what is it? It's not. My name's Don Webb, certified industrial hygienist with T. Harris Environmental. And this is my contact information. So prevention through design is an initiative by NIOSH on anticipating and designing out hazards and tools, equipment, processes, materials, structures, of an organization, and has been long recognized that the most effective way to prevent occupational injuries and illness and fatalities is at the design stage. So this prevention through design initiative was a national initiative to prevent occupational injuries, illnesses, fatalities. And the mission, best results are from eliminating hazards and controlling risks to workers at an acceptable level at the source as early as possible in the life cycle of the equipment, products, and workplaces. And all risk will not be eliminated by these controls, but it may go a long ways to reducing long-term injuries and illnesses. And the traditional control programs usually were administrative personal protective equipment. And this standard has been developed and is also morphing into other standards that probably you folks are familiar with ISO and ANSI standards. These would be familiar to designers. And so the traditional role of the hygienist has been to recognize, assess, and control. And many health and safety professionals, they have already recognized the issues, the hazard, and rather than collect samples and assess the hazard, we can move quickly to control the hazard, and then you assess the hazard and its effectiveness. And this goes well with control banding, which is a GHS classification, which classifies hazards, not necessarily their exposure limits. So prevention through design is not new. And it's this Code of Hammurabi quite a while ago. And if you build a building and it doesn't fall and it's not done properly and it falls down, it kills the owner should be put to death. That's a bit harsh in today's environment. And here's a statement by DuPont. The CEO of DuPont was required to live with his family on the site of manufacturing facilities for explosives and other hazardous compounds. So prevention through design initiative looks at tools, processes, materials, structures, and the organization of work. And as Einstein said, we cannot solve our problems with the same thinking we used when we created them. We have to have fresh thinking, think outside of the box. And this, I think, is a very important concept, that when you're dealing with human behavior, if we can reform the environment stop trying to reform the people. They will reform themselves. And one of the issues that the U.S. Air Force came to realize that crashes that were in accidents that were occurring in the Air Force initially, and we don't hear it as much now as we used to, but it was blamed on pilot error. Well, they've determined that it's really not pilot error, it's a systems failure. So we get away from the idea that, and we design things so that people's behavior and operators and workers' behavior cannot create hazards. So from an engineering and administrative control perspective, engineering controls protect employees effectively without placing the primary responsibility of implementation on the employee. And it's so easy for managers, designers, construction activities to put our control of exposures on personal protective equipment. And they're relying on the employees and the individuals to protect themselves by using protective equipment. But in the long run, the company is going to be responsible for the compensation at the end of the day. So the companies might as well do the engineering controls, and then they are controlling people's exposure, not depending on hearing protection, respirators, these sorts of things. So the early studies of design-related accidents and injuries, we see that in Australia, there was 37% of the workplace fatalities were design-related issues. And in Washington, California, they did another study where 22% of injuries occurred were partly due to design. 42% of fatalities were linked to design. The European Foundation studies said that 63% of all fatalities are attributed to design decision or lack of planning. And this 1991 study concluded 60% of fatalities, fatal accidents resulted in part from decisions made before the work began, which is code for at the design stage. So prevention through design was a concept that was beginning to be covered, but not very well in the literature, and it was seldom found in management guides, and usually was the result of corrective action, not from incident investigations. More than 1/3 of accident investigations list design as a cause. So this is a very familiar diagram, and we see at the top we have the elimination, you design it out, or substitution, you outsource, or somebody else looks after that hazard. And then primary control is engineering controls. Administrative controls are always hard to implement because of work schedules, rotation on the shop floor, and we'd really rather not talk about personal protective equipment. So in any project schedule, usually at the project design stage, there's enough information to be able to implement engineering controls for controlling hazards. And as it says on the left, the ability to influence safety and health is much higher at the design stage. And it goes down quite rapidly. And at the detailed design stage, and I think we might classify detailed design as maybe 60% of the engineering design has been completed. So you still have a decent opportunity to implement engineering controls. And of course, at the construction stage, it's almost too far out. And the occupancy, you almost have no effort, no ability at that point. And as one of the main features of prevention at the start is the economics that are much, much greater if you can introduce value statements for the engineering controls or other hazard reduction. And as further into the project you get, any modifications, amendments, changes to the scope, the costs go up rapidly. So in this diagram, we see that it's just illustrating the same thing, that business concepts and design at the early stage have good payback for most organizations. So some of the earlier research also said that benchmarking of prevention through design in the UK, health and safety spread through a project team. And early on, why there were even safety notes on drawings, and constructability versus safety constructability versus constructability. Design duration, 77%. If you do this early, there would be no change or decrease. Construction productivity, they said that it would increase. Construction worker and health and safety said 90% increase if designed ahead of time. So this is just an illustration of this similar concept, integrated health and safety with business process and better efficiency, cost effectiveness. So prevention through design pushes toward doing cost benefit analysis. And as prevention through design has found itself in these standards that engineering companies are probably working with to achieve acceptable risk levels, prevent or reduce risks that produce injuries or illness, reduce the need for retrofitting, and address hazards and risks not addressed at the design stage. And this standard is based on the risk reduction hierarchy of controls. Here's the ANSI standard as to address preventative risk assessment at the design and redesign phase. Provides a framework to implement risk assessment concepts within the various phases of the system's life cycle. And another initiative for prevention through design, the NIOSH program, is to diffuse the principles through engineering textbooks and coursework. Very little engineering technical schools have introduced these concepts of engineering controls. So the educational goals would be to inclusion of prevention through design engineering textbooks and curriculum, disseminated engineering education modules, and educational programs to health and safety professionals, and provide accreditation for engineering and architectural programs. Engineering and architectural licensing exams. And this was a tool that was developed by these folks in construction safety and project design. It was a safety design risk evaluator, when you can use it to determine levels of risk associated with their design and create building designs that minimize the risks to construction workers. And a NIOSH publication is designed to prevent falls through roof of parapets. Parapets are the wall assembly extend above the roof and prevent falls. And these can be prevented if you do it right. And here was another issue, their statement that prevention through design is not new. Back in 1440 BC, if you build a house and make a parapet around the roof, so you may not bring guilt and bloodshed on your house if someone falls off the roof. And much more recently, this was a bridge that was built in England, and the master builders consider worker safety during construction. And this was unheard of in those early days. The specialization and compartmentalization in modern times has led to designers saying, work safety is not my job. But I think the master builder idea is coming back. Here's a number of publications, guides, standards, consensus standards that prevention through design is having an impact, and it's being incorporated in NAPFA standards, ASHRAE standards, ANSI standards. And this is another example of two of the standards where they've prevention through design guidelines in addressing occupational health and risks. So many of you, we've all heard of LEED certified green buildings, safe sustainability. Well, this MGM Resorts building in 2009 or 2006 and 7 in Las Vegas, this received numerous LEED Gold Awards by the U.S. Green Building Council. The only problem was there were 6 construction deaths in 2 years. So they were more concerned about some sort of sustainability than about workers' health and safety. So what was missing? Well, nobody was giving any credits to for safety in these buildings, and it wasn't just the occupants, it was construction workers as well as occupants. So the green designers, they weren't thinking of construction workers, operation and maintenance workers as occupants throughout the life cycle. It was only after the building was put up where you were awarded credits. So how sustainable is dangerous technology? So in February of 2015, the U.S. Building Green Council modified their points awarding system and awarded prevention through design credits. So prevention through design has been picked up and is incorporated in a number of international laws. The UK have this construction design management regulation. Singapore have a design safety pledge, and other countries have also done this. And for any of the professional organizations, they have to be concerned about the ethical reasons for doing this. They are held to a higher standard, and engineers should and have been held accountable for safety and health and welfare. And American side is civil engineers have a similar code of ethics. So prevention through design is just systems or process safety. We practice process safety systems and may often focus on property environment more than on workers, safety systems. And what often gets done is we must trust. So if you're not sure, well, equip everyone with PPE rather than designing out the hazards. So there's barriers to this integration, which is plagued occupational health and safety professionals for a long time, is management's reactive to it. And from an industrial hygiene perspective, safety and the environment get management's attention right away. Industrial hygiene is more of an afterthought because a noise hearing loss compensation claim will be 10 years down the road. So as hygienists, maybe we haven't done a very good job of making sure that management understand what the consequences are for not being proactive. And this is where safety and occupational health should be more concerned and understand about the costs and emphasize that occupational health and safety is not considered a cost, but it should be considered an investment. Cost-benefit analysis rarely applied to justify occupational health and hazards. Retrofitting is never cost-effective. So prevention through design is not reliability engineering. For many, reliability engineering replaces safety systems. Assumption that if it's reliable, it's safe. Focusing on failures failures is a trailing means of determining how effective your health and safety program is. Reliable systems can be unsafe. So the focus of prevention through design is to allow companies to assess business value with respect to health and safety effort, tools, and engineering. And here we are with this diagram again. We're focused on the engineering controls, isolation, and guarding. So this was a study done for people in the construction trades would know that you have this rebar in concrete, and it has to be protected for impalement. And someone probably out there on the construction site, maybe on some cold day, said, well, why don't we just take the rebar and why don't we make it, like they say, get bent, candy canes? And said, why don't we have our spec writers to include this specification when we are putting in rebar? That way we don't have to protect it once it's there. Here's another illustration, which is happening with builders, is they assemble the roof on the ground. And the features of this would be you don't have the materials handling up and down ladders or lifts or whatever, and you don't have the same issues of fall protection. Although this, you would need something at the edges, but this roof section can be completed on the ground, and it's probably much more efficient for labor perspective and hazard reduction. So once you get it finished, you elevate it to the position that you want, and you've eliminated a lot of hazards from putting this roof section together. So Shell Oil, they have a policy on their sites. There are no ladders. So we can eliminate all these excursions of height, and we can also, our schedule is even better. So construction is plagued by a lot of ergonomic issues, and prevention through design has a focus on eliminating or reducing a lot of these lost time cases. Worker comp case, overexertion, we could see that by proper design, you could reduce the overexertion. You have lifts and various other kinds of repetitive motion devices to reduce the risk from that. And it's been estimated that 50% of total claims are ergonomic. 60% of total costs are ergonomic. So there's a real savings if we can engineer this at the beginning. So what has also been an impediment with many of the engineering companies, and this probably is more so in the US than it would be in Canada, but there's liability issues with this prevention through design. And it's so easy to make a legal case out of it and say, well, we can't do it because of the liabilities, and we don't want to accept the liability because we don't know how, we're not the end user. So prevention through design requires the input by many different people, many stakeholders, not just the designers, but the engineering and the procurement. And as it suggests here, many of the people who are using or in the workplaces, they know the problem even if they don't know the solution. And newer employees may see what older employees miss or may not see. So here's a slide showing that this smart engineering, or it could almost be code for prevention through design, is taking place in the manufacturing industry. So here's an example at the bottom where landing gear went from 72 parts and 1,720 fasteners to 2 parts and 35 fasteners. Any of the parts assembly people will tell you that 75 or 70% of the labor costs is assembling the parts. So if we can reduce the number of parts and fasteners, then there's a huge savings. So management policies and responsibilities should be spelled out in the assigning roles and responsibilities for management. Responsibilities should be designed within the organization to address opportunities to prevent risk. So they should be able to award points for reducing the risks. Safety design reviews are an opportunity to adequately anticipate, identify, and assess, communicate, control risk during design and redesign phases. So if this is done properly, then we have new design projects, we anticipate hazards and analyze the foundations. Same with redesign. So our product will be safety, quality, low cost, improve morale and reputation. And this process can take the form of a risk assessment matrix with standard notes, and then it requires a probability of occurrence and severity of harm. And here's an example of a risk assessment matrix. You go from negligible to marginal to critical to catastrophic. And then its activity is it frequent, or probable, or occasional, remote, or improbable. This allows any organization to prioritize their risk mitigation process. Top management shall require that personnel to perform risk analysis be trained in identifying hazards and how to mitigate them. It's not everyone can do it. Not everyone has the background. So this would require a team effort, and hygienists, health and safety professionals should be on the team. So a team should be able to address one hazard, that one hazard does not inadvertently increase another hazard. So risk reduction and control, the initial risk evaluation indicates the risk. Further risk reduction, hierarchy of control model is used to select possible risk reduction measures. And some of the risk reduction matrices include a warning statement. So process and personal safety versus process versus personal safety. And these two are often treated separately. So we remember the Bhopal incident. Personal safety and personal process safety was poor. Poor culture appeared to be the cause. And we know from the Deepwater Horizon, personal safety appeared high. They were at the time of the blowout. They were awarding Transocean personnel for safety awards. Well, it didn't quite work out that way. So if anyone has been involved in a HAZOP study, you would know that the HAZOP study is a study of deviations of are process oriented and not focused on human errors, but the deviations that are identified allow health and safety professionals to understand the process, understand where there might be problems, and gives them a better chance to provide solutions at the design and operating stage. So follow-up is also effective for reliability, for implementing control measures. It should be evaluated to determine if the risk is adequately reduced or additional measures were needed. If the risk is not acceptable or unintended consequences were introduced, control measures, the organization should take steps to reassure the risk and consider measures. So as some of the same barriers to design is many IH professionals spend too much time putting out small fires, and they can be burdened by compliance forms, fill out, to meet the regulatory requirements, and not enough time perhaps to be looking for opportunities to reduce hazards and risk. And what's becoming more important now is health and safety, environmental professionals do not understand business metrics. And then as frequently we hear, nothing can be done. Prevention through design is a corporate deed without corporate direction or standard. Engineers and designers have not been trained in university, technical schools, prevention design, including engineering and economics. And then we'll say these efforts are not perfect. So unless we can eliminate all failure, we're not interested. So some of the design myths are, if it meets minimum requirements or minimum regulatory levels, then it's safe. These costs can be prohibitive. Certainly they will be greatly elevated once the process is up and running. And if the project planners have not allowed enough time for prevention through design, they will want to eliminate this design risk assessment. And in many managers' ideas, the way we've been doing it safe enough. We've done it this way. Our injury experience is not that bad, so we're willing to live with it. Low levels of control greatly reduce severity of harm. So avoidance means preventing by design hazards from entering the workplace. Good risk avoidance statement begins with no statements, such as shall use, no elevated work. The purpose is not to protect the worker health at our convenience when the analytical methods and OELs align, but rather to protect at all times. And hygienists have the responsibility to be an exposure controller. And this goes back to this paradigm shift for recognize, control, and assess. Many health and safety professionals, they know that the exposure probably is not over an OEL, but there are engineering controls to reduce it even more and to not be relying on personal protective equipment, which management have limited control. So science is about learning, not about knowing. Insufficient resources exist to collect sufficient data to defend knowing. So if we take the approach that we're an exposure controller and not a scientist, then we can have a different view of why we're doing what we are. So say health and safety is a good business, employee morale, protection of valuable resources, control costs, direct and indirect. Safety excellence correlates with quality, efficiency, and profitability. And International Labor Organization, they have recruited economists to work with occupational health and safety branches in their group, and they want to evaluate adoption of policies and programs taking into account economic dimension, and the manuals and guidelines to help constituents better address economic results of health and safety conditions. And the global practice demonstrates every dollar invested in an effective occupational health and safety program will win back $4 to $6. So the business case, why a business case? Changing responsibilities for, I have industrial hygiene professionals, but it would certainly be with occupational safety professionals, environmental engineers. The survey indicated that many IH professionals spend a large percentage of the time just doing pure industrial hygiene or occupational health and safety, training, etc. IH professionals must diversify their knowledge, learn Sigma, risk assessment, risk management, HR, business metrics. So why a business case? Provides reasons for initiating the project. Decision-making tools determine the effect of decision on profit. These are the things that bottom line managers understand. Project mandate done before the project answers the question, what is the value for the company? And the manager will always be saying, what's in it for me? And this saying with Warren Buffett, price is what you pay, value is what you get. So one of the roadblocks to comprehensive business case development is related to the non-financial benefits and challenges. And there are many, and it's so hard at times to find out or to place a value on these metrics: employee performance, confidence in the program, company reputation, supplier relations. These are non-financial benefits that are hard to quantify. But the business case is presented, you have the financial analysis, the non-financial outcomes, and then you have a value. Evaluation of non-financial benefit provides a missing link for non-profitable projects that add to business sustainability. So even though they are hard to quantify, some of these benefits do provide business sustainability. So here's a business objective matrix. So we can do business sustainability, excellence in EH&S, retained talented employees. We can have a scale on this to give us to prioritize an objective. So financial assessments, how to talk to management so that they will listen. We calculate the financial ratios, estimate the cost and savings. Is the project well designed? Defines tangible benefits, allows you to communicate with management in their language. These are some financial assessment terminology. Cash flow refers to cash in and out of the business of the project. Time value of money. The accounting people and managers, this is very important to them. The idea that money you have now is worth more than when you spend it. So there may not be a lot of incentive to re-engineer something. Interest rate, discount rate. So another thing, present value. The further out the cash flow occurs, the less value it has at the present time. So if you spend it now, you have to know that it'll be worth it in the long run. Present value of 5,000 3 years from now is 3,700. So hygienists should learn business metrics. Think outside the box. Get your management's blessing. One of the biggest hurdles to industrial hygiene is communicating with senior management with respect to these business metrics. Senior management may not be interested in your risk assessment process, but they are interested. Costs or savings are discussed as a chance to demonstrate added value. And safety and occupational health professionals have to demonstrate their added value to the organization, more than just so-called keeping the management out of jail. So purchasing specifications are also important. In the conceptual design, you identify noise control standards. And I was in one project where the engineers thought that they needed strict noise control on a diesel genset. And when we looked at the economics of it and the people involved, there's better ways to spend the money than this comprehensive noise control where very few people were just doing process checks and occasionally when they run the diesel gensets. So this purchasing specs can be useful. They are useful early on to identify what you need, and but I think health and safety professionals should understand the limitations of some of these specifications. So here's an example of a painting operation, and it was a new process, so they're examining two options: local exhaust ventilation, respiratory protection. And the coating operators were using the N95s, P100 respirators, safety glasses. Glasses are coated with paint after just 10 minutes. And this really resulted in very poor quality. So that was one of these hard to identify costs of poor quality. So case was prepared where the respiratory protection program and the health and safety professionals should try to understand what the costs of a respiratory protection program is. This one, as you could see, we have medical surveillance. This is an annual. And you have all these costs with respect to this program. And when you put that into this spreadsheet and this time value of money over a 5-year period, then local exhaust ventilation was $385,000 to start with, and then you had design, and the respiratory protection program to start was $94,000, and over the in the 5-year period it worked out to $302,000. And I can't see the bottom of this, the total project costs, but I assume that you can see it. So this is further working the economics. So the local exhaust ventilation added $750,000 per year in new products, and the total revenues, the net cash flow at the end of the year, the cumulative cash flow, and it's down at the bottom. I can't see it on this, but I've highlighted it. Anyway, when you crunch the numbers, the discount cash flow and a lot of these things where the internal marginal rate of return of 10%, it works out to an internal rate of return for this project would be 136%. The payback period is 0.7 years, and their simple rate of return on investment is $595,000. So it's quite likely that this project would be given the go-ahead. That is the exhaust ventilation being done up front. And again, you relieve the burden of the operator to have to manage personal protective equipment, respirator protection, and all the hazards that seem to be entailed. So here's another example of a model that we can use for noise control priority factors. So if you put these variables, the number of employees affected, potential for produce significant damage, and problem solution, potential success factor, productivity factor, many of these noise control options may require special shrouds and enclosures. Well, this may be an issue for maintenance. So this productivity factor may go way down because maintenance need a certain amount of time, so that equipment can't run. And there's the estimated cost of controls. And in this slide, we have these different operations that we have assessed. Spray booth silencers, spray cabinet department has spray booth silencers. So in any case, the air gun exhaust mufflers show that it has a much greater payback than these other options, other priorities that one want to choose. And part of the reason is the cost per employee. So many people were using the air guns. So there was 25 people who would benefit by the mufflers, where the laboratory exhaust muffler, there was only 2 people. So it would be in second. And these others were very expensive and didn't really protect that many people. The sanding department, they would receive a reasonable payback to do that as well. So significant payback must be demonstrated for the hazard control at the design stage so that the project engineer will have confidence the capital is well spent. Personal protective equipment option preserves capital at the project stage, but shifts the hazard control burden to a third-party operator. And these comprehensive personal protective programs without costly retrofits are a long-term drain on cash flow without the confidence the hazard is being controlled at a high level. And this was some studies done by some folks at the University of Puerto Rico. And this is just about the end, and these are some references that are commonly used. Engineering economics, which the health and safety professionals should buy the book and entertain questions if you have any.
I think we're one question.
People were able to unmute their own.
Yes. So we've allowed everyone to unmute.
Yeah.
So here's a question that we have in the chat bar. Question asks, what safety through design regulations do we have in Canada or Ontario?
Probably it's section 25 of the Act. I mean, the owners will take all reasonable precautions to protect people under the circumstances. And if they want to just depend on the PPE, then the organization is at risk for compensation down the road. If for some reason, the regulator will say, even if you have these programs, well, we don't care. I guess it isn't working. And with respect to noise, there was a number that was kicked around a while ago that if you couldn't do it for $10,000 or less, then maybe it wasn't worth it. But the economics of that may have changed quite a bit.
Is there any other questions out there? We ask that you type them into the chat bar here. I don't see any other questions.
There's still 10 minutes.
I think, yeah, there's no questions. I think let's wrap things up. everybody for joining us today.
Okay, if there are no other questions, then thanks for joining, and don't forget that at 2 o'clock, ergonomics at the office and working from home. And at 4 o'clock, there's infection control with respect to COVID-19, cold and flu season. So we're welcome to join these sessions. Thank you very much.